We are going to discuss the last method for solving the system of linear equations. We have already discussed the phi method. We're having the method Gauss elimination method, Gauss-Jordan method. Then we have row echelon form, reduced row echelon form. Then we find in A inverse by using the elementary matrix method. Then we have discussed just today the inverse method, finding A inverse by finding the method of cofactor. The last discussion is about the Cramer rule. It's very interesting. Here in all the methods we have discussed, we can find the all value of the unknowns. If we have three equations x, y, z, we can find all the whole vector, the value of x, value of y, value of z in a method. But here in Cramer rule, we can find any one of them. We can find only x, we can find only y, we can find only z, or we can find all of them. So that's very interesting, number one. Number two, here we only use determinant to find the value of the unknowns, the solution of the system of equation. Only determinant we use. We have to solve 4 determinants for the system of 3 equations, we get the result. So I explained you the method. So we are having here the system of equations, we can write in a matrix form. I get a matrix form of this one, matrix equation form. I am having here this my A11, A12, A13, A21, A22, A23, A31, A31, A32, A33, and then I have my unknowns. My unknowns are x, y, and z, and I am having here, the constants is b1, b2, b3. Now here I define 4 determinants. This is my a, and this is my x, and this is my b. So first one is my a. My a is the matrix of coefficient. So my determinant of a is equal to a11, A12, A13, A21, A22, A23, A31, A32, A33. So this is my matrix A, determinant of matrix A. Now I'm going to use this and I can just write here determinant of matrix A1. So it's very interesting. What's my A1? My A1 is that it replaces my first column in matrix A by the constant. So I'm going to write here B1, B2, B3. So I replace my first column, other remain the same. Other remain the same. I get here A12, A13, A22, A23, A32, A33. So this remain the same. Now I write here matrix A2 and determinant of that one. So I'm having here my determinant. What I'm going to do, I'm going to replace the second column by B1, B2, B3. A2 mean I replace second column by the matrix constant vectors. This is B1, B2, B3. Other values remain the same. So I'm having here the A11, A13, A21, A23, A31, A33. This is my A2. Now I defined A3. And A3, I'll get here this equal to determinant of this one. Now here I replace first column, then second column. No, obviously I'm going to replace the third column. That become here B1, B2, and B3. And other entries remain the same. So I'm going to get here A11, A11, A12, A21, A22, A31, A32. I have only condition on one of my determinant. This determinant of A must not be equal to 0. I can write my solution by using the Cramer rule. By using Cramer rule, I say what's my x? My x is equal to determinant of A1 over determinant of A. My y is equal to determinant of A2 over determinant of A. And my z is equal to determinant of A3 over determinant of A. We say 4, 4, we'll get here 4 values, x, y, z, and w. We get here 5 determinants. We find A, A1, A2, A3, A4, and then write the similar way. We get here of any size. So as I said, I want to find x, then find a1 and a, I can write my x. I want to write only y, then I get my a2 and only a, I can get my y, and similarly az. So I will explain you with the help of the example. I use this example to apply the Cramer rule explain. I have 4x plus 5y equal to 2, 11x plus y plus 2z equal to 3, x plus 5y plus 2z equal to 1. We write in the matrix form. So our matrix form is here, this is equal to 4, 4, 5, 0, 11, 1 and 2, 1, 5 and 2, and this is my x, y, z, x, y and z, and the right hand side I am having here 2, 3 and 1. So I have A, what's my A? Matrix A is 4, 5, 0, 11, 1 and 2, and I have here 1, 5 and 2. Now I write my matrix A1. In matrix A1, I just replace the first column by the constant, that is 2, 3 and 1, 2, 3 and 1, and the rest I write here, this is 5, 0, 1, 2 and 5, 2. Then I write my matrix A1, I write here A2. So for A2, I am having here the second column, I change it by 2, 3 and 1, and the first column is 4, 11 and 1. Second column is this, to replace this one. Third column is 0, 2 and 2. So then I may write my A3. For my A3, I just replace my last column by 2, 3 and 1. And my first column is 4, 11 and 1. My second column is 5, 1 and 5. Now I find the determinant of this one. So I find determinant of A by opening it by the first row or first column, or any row, any column you like. This is equal to minus 132. Then I find determinant of A1. Determinant of A1, I calculate it, I get the result is equal to 36 minus 36. Then I have determinant of A2. Determinant A2 comes to be equal to, that's equal to minus 24. And determinant of A3, determinant of A3 is equal to, the result is 12. Now I have this determinant of A1, A2, A3, and this is not equal to 0. This means we can have the result. What's my x? My x is equal to determinant of A1 over determinant of A. So my x is equal to determinant of A1. Determinant A1 is equal to minus 36 over minus 132. We divide by 12, we get here 3 over 11. This is my x. Now I find my y. My y is determinant of A2. Determinant of A2 is minus 24. Over determinant of A. Determinant of A is minus 132. Then again divide by 12. We get here 2 over 11. There's my z. My z is equal to, I take here determinant A3 is equal to 12 over determinant of A minus 132. Make the division, we get minus 1 over 11. So I get here my solution is, my x is equal to 3 over 11. My y is equal to 2 over 11. And my z is equal to minus 1 over 11. So this is the solution of this one. So we are having here more problem in the worksheet, in the notes, and I have put my notes in the description. I have given the reference to that one, and you can take it from your notes. Again, if you like this one, subscribe it, and also press the bell icon so that you get the notification. We are going to continue this one. Our next discussion will be about the vector calculus. We are discussing linear algebra, and we have finished the system of linear equations and determinants. We have also discussed. We discussed 5 methods for this one. Inshallah, we'll continue with more.